Although the concept that is used in this question is very straightforward, but the fact that in this case, uh, replacement after the removal is done by different things at each and every step. So in the first step, replacement is done by water. In the second, it's milk, and then it's water. So this particular thing makes this question a little complex, or I can say a little lengthy. If you are not very much familiar about this concept, then it will be difficult for you. Otherwise, this is a moderate enough question. So let's have a look at it. First of all, the formula that we are going to use here. So in removal and replacement, we have a standard formula, that is final concentration or the fraction is equal to initial concentration or the fraction multiplied by total solution minus the solution that we are removing divided by total solution, and then raised to the power number of steps, the total number of steps in which this is repeated. Okay. Now, as in this question, replacement has been done by different things at every step. So we'll not be raising the power. Okay. So we'll be using this formula for each and every step separately. Okay. Also, one thing needs to be understood, that if the replacement is done by water, the formula will be applied on milk. So that is why, like if let's say in the first step, you can see it is replaced by the same quantity of water. So here on both left hand and right hand side, the final concentration of or fraction and the initial concentration or fraction will be kept for milk, not for water. Okay. Now to make the calculations easy, I'll give you a method using which you'll be able to solve this question in less than 45 seconds if you just know the basics of this concept. Okay. Now the method that I'm going to use is the backtracking, the method of backtracking. So I'll not be using a conventional approach, which might be a little lengthy, but I'll be using backtracking approach in this case. Okay. So let's start from the end. So question says that as a result, the percentage of water in the final solution is 33.33. Now it will be better if you'll be using percentage equivalents of fractions. Okay, so just convert these percentages into their fractional equivalents. So final concentration of water. So water is 33.33 percentage, that is 1/3. So milk here will be equal to 2/3. At every step, I'll be keeping track of the fraction of water and the fraction of milk which is left. Now in this step, 66.66, that is 1/6 of the solution, is removed and replaced with water. So we are going to apply the formula on milk. So formula is final fraction of milk, which is given as 2/3, is equal to initial fraction of milk. So fraction of milk, that means before this step. Bracket. Now what? I'll keep it in the bracket. Now consider this part, total solution minus removed upon total. What is this? This is actually giving you the leftover fraction of the solution. So if from the solution 16.66, that is 1/6 of the solution is removed, then 5/6 of the solution will be left. Okay, so this is how you can make this question look easy, right? So I can say that initial concentration of milk will be equal to, so we'll have cancellations here. So 3, so it will be equal to 4/5. So before the third step or after the second step, I can say that fraction of milk was 4/5. So the fraction of water will be equal to 1/5. All right. Now let's look at the step before this. That means the second step. Okay. Now here in this step, 25% of the solution, that is 1/4 of the solution, is removed and replaced with the same quantity of milk. So replacement is done by milk. So the formula will be applied on water. So I'll keep final fraction of water, which is 1/5, is equal to initial fraction of water, bracket the leftover solution. So if 25% is removed, that means 1/4 is removed. I'll be left with 3/4 of the solution. So initial concentration, initial fraction of water in this case, because the formula is applied on water, will be equal to 4/15. All right. So let's write both these things. So water after first step or before second step will be 4/15, and the fraction of milk will be equal to 11/15. How am I writing fraction of milk if fraction of water is given? So just by subtracting it from 1. Okay. Now moving on to the first step. So firstly, 20% of the solution or 1/5 of the solution is removed and replaced with the same quantity of water. So replacement is done by water, so formula will be applicable on milk. So 11 upon 15 is equal to initial fraction of milk bracket the leftover solution. 20% 1/5 is removed, so 4/5 will be left. So initial fraction of milk here will be equal to, so cancellation, it is 3, so that is equal to 11/12. So this is the initial fraction of milk. Now let's see what do we have to find out. The last statement says that find the concentration of milk in the original solution. So we have already got the fraction of milk, and now we can convert this into its percentage equivalent. So 11/12, you must remember, you can write it as 1 minus 1/12. 1 is 100%, 1/12 is 8.33 percentage. Okay, so the initial concentration of milk in the original solution will be equal to 91.66 or 91.67 percentage. Okay, now you can check among the options. So you have option A as the correct answer, that is 91.66 percentage. Yes, it is the correct answer.